All right. First off, let me introduce myself. My name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of the Fischertechnik Education Robotics Competition Set. Now, this set was designed to provide students with the tools and the background needed for participating in robotic competitions. And this is whether you're talking about something at the local level, or even if you're looking at participating in larger scale national or international competitions. Things like RoboCup Junior, which I know uses Fischertechnik. Now, more than that, this set was also designed to enable educators provide students with a project-based standards-focused curriculum program, which involves inquiry, design, and problem solving. And the curriculum for this set, like the curriculum for Fischertechnik's two other curriculum-focused project-based sets, which are the STEM Prep 2.0 and STEM Engineering sets, which are the focus of their own webinar. If you're so inclined, you can sign up for that as well. Well, the curriculum for all of these sets was created especially for Fischertechnik and Studica by noted educator and STEM expert Tom White. So just to start things off, most educators are, of course, well aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. And of course, if you're involved in any aspect of education these days, you really can't open an email or go to a conference or a website that's involved with education without seeing STEM highlighted or talked about in some way, shape, or form. And the reason is, of course, really pretty simple. Just to quote the Bipartisan Congressional STEM Education Caucus and their report on the importance of STEM education, they stated that STEM education is necessary because it helps provide the scientists and the engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds a foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered kind of a matter of national security. See, on every level, the world around us is changing at a frantic pace, and STEM education, it could be argued, enables us both as individuals and as a nation to understand and keep up with these rapid changes in technology, changes which, of course, in turn are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this really requires us to keep pace with the rapid developments occurring all around the globe, where countries such as China and India are making major investments in state-of-the-art infrastructure. And while all of that's well and good, and of course we should all strive to be good citizens, many students might also ask, so what's in it for me? Why do I want to study engineering? Or why would I want to study coding? Or, fill in the blank. So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce, and this was from a few years ago again, released a set of projections for the decade leading up to 2018. Now, these projections indicated that STEM occupations were expected to grow by 17%, compared with just 9.8% growth for all other occupations, excuse me. Now, in March of 2017, the Office of the Chief Economist basically released a STEM Jobs 2017 update, which was taking a look at how those numbers were playing out up through the year 2015, with still, of course, 3 years left to go in the initial projection for this project. And what they found at that time was that while the projected STEM growth, and once again, this is just up to 2015, was a bit less than they overall expected to reach at the end of 2018, in this case being that they had reached 14% growth, which is really pretty impressive, but they'd reached 14 on the way to the full 17. But comparatively, the actual growth for non-STEM jobs, which again was expected to eventually reach 9.8%, was at this point only a fraction of that, 1.7%, a stark difference. And someday I'm going to find out how those statistics played out all the way, but for right now, we'll leave it at that. But here's a statistic I also like to share that should give anyone entering the job market of the future pause, and this comes from J.D. Chesloff in his Education Week article from March 2013. And to quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. Now, in STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the US Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in the article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, just to go back to that STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced just a few minutes ago, here are 3 key points mentioned in that report that are well worth keeping in mind when considering the importance of STEM education of the worker. Key point 1, STEM workers command higher wages, earning on average 29% more than their non-STEM counterparts. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs, things such as scientists or engineers or things of that occupations of that nature. To quote the report again, STEM degree holders enjoy higher earnings, regardless of whether they work in STEM or non-STEM occupations, end quote. Now, there was a video I saw a little while ago on YouTube, and it was posted by the Women's Forum for the Economy and Society. And the title of that video, I think, is really kind of sums up things nicely. And the title of the video was that every company is a tech company. Now, what I take from that and what I think students want to keep in mind is that whatever a company makes, whatever a company sells, or whatever service it performs, at some point, STEM skills are required to help that company fulfill its mission. Moving back along, key point number 3 relates to job growth. Employment, quote, employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, this being 24.4% versus 4% growth respectively. And STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations. Now, the trick for educators is, of course, to find methods for getting students involved with STEM, and in particular, the most highly in-demand technology-focused skill areas, and this would be things like engineering and coding, and to do so in a way that engages students' interest and creativity, and while at the same time, it also helps to develop the work habits and the way of approaching problems and the skills that they're going to need to draw on as they move forward in their careers, both their academic and their working careers. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and the students have to discover exactly why they occurred, or where students have to find a way to achieve a specific outcome. Now, they can do this through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of what we call hands-on project-based learning. And that brings us to the focus of today's webinar, of course, the Fischertechnik Robotics competition set. Now, as I mentioned before, this set is one of 3 different standards-focused project-based sets that are currently available from Fischertechnik. The other 2 sets, which are STEM Prep 2.0 and STEM Engineering, are again the subject of another webinar presentation. So we, of course, won't delve into those too deeply here, instead focusing, of course, on the robotic competition set. But in any case, each of these 3 sets have been designed to provide a guided, project-based learning experience, which comes complete with detailed curriculum, all, of course, using the unique Fischertechnik building system. So that might, of course, bring up the question, so what exactly is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike a lot of other popular construction sets that use more of a stacking way of doing things, Fischertechnik was created with more of an engineering mindset. Now, with Fischertechnik, the core building block is unique because it allows you to attach from all 6 sides. And because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to lock in place, sliding together using a tongue and groove assembly method. And the hundreds of different parts available will also help engineering students to address very specific design needs. Fischertechnik was originally created back in 1964 by German inventor Arthur Fischer, who's shown here, and he's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he is also known now as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. And I say now because there was a little bit of dispute about that, but eventually it was proven that Mr. Fischer was indeed the inventor of the nylon wall plug. Now, his company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as many components used in the automobile industry. And they also provide consulting services in regards to high-end manufacturing processes, automated processes, things of that nature. Now, I'd also like to mention that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots. And this was using the original pre-Macintosh era Apple computers, just like the ones you see on the screen now. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related subjects. These, of course, are things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and so much more. Now, Fischertechnik has also been used by numerous companies like Porsche, Daimler Chrysler, and BMW, just to name drop a few, for industrial simulation and training purposes. Now, in addition, over the last couple of years, Fischertechnik's line of pre-assembled simulation models have also found wide adoption for demonstrating and exploring the world of IoT, also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, I will throw in that besides the fact that there are many of these simulation models where companies and lab use and what have you, where they've modified them to do IoT based exploration and experimentation, there are now also special IoT focused models that Fischertechnik makes that can be monitored and controlled from a cloud-based website. So if you want to learn more about those, we have a separate webinar for talking about them. So you can look that up as well. Anyway, the Fischertechnik robotic competition set is designed to provide educators with a clear and detailed pathway for exploring the subjects of robotics and coding, that through the focus of learning how to create mobile robotic models for use in a competition setting. The set itself is designed for use by teams of 2 to up to 4 students at a time. It contains 670 components, all of which come packed in a sturdy plastic retinal storage box, such as you see on the screen right now. The set is designed to provide all of the materials that you're going to need. By this, we mean both the physical and the instructional materials. And it's designed to enable teachers to offer a complete, standards-aligned, curriculum-based, competition-focused class or after-school activity, if that's how you choose to conduct it. Now, the curriculum used with the robotics competition set was created especially for Fischertechnik and Studica by a man named Tom White. You can see a picture of Tom over here. Tom is a noted educator who's been involved in STEM education since the 1970s, and he's known for designing programs both for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing subject areas such as CAD, CAM, control systems, digital control, additive manufacturing, and other like topics to the classroom. And currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this isn't the first time that Tom White has created a curriculum around Fischertechnik. Now, besides also being the creator of the curriculum used in the STEM prep and STEM engineering sets, as well as a pair of elementary focus sets called Introduction to STEM for using those with students grades 2, 3, and 4. Besides this, Tom has also incorporated Fischertechnik in many of the educational programs that he's been involved in designing over the years. And when I talk with Tom, he's often said that he likes Fischertechnik because he thinks it's kind of the ideal construction set for any kind of an engineering-based curriculum program. And some of the reasons he's given for that are things like he likes the fact that the materials can be used and reused. Things can be built and then taken apart and reassembled into something completely different. And he also likes the versatility of Fischertechnik and the fact that it offers so much more economy than just say, let's say, just purchasing an expensive piece of equipment, something like a robotic arm where you're only going to perform a few experiments with it and then it goes back and sits on a shelf for another year. And he also appreciates that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, offers almost limitless creative opportunities for engineering students. Now, when Tom Waite designed the curriculum for our 3 project-based learning sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he'll sometimes say that he sees his own strong point as being the creation of curriculum, something like this, more so than, let's say, conducting a lecture. With this in mind, he focused on creating a detailed curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, so that instead they could just focus on the needs of the students. He also makes sure to include a special tutorial section right at the beginning of the curriculum to familiarize new users with how the unique Fischertechnik system works. And he made sure that each section of the curriculum is designed to clearly spell out how everything will be addressed in that specific unit. In short, he designed the curriculum and selected the components included in each set to essentially act as a turnkey solution that would provide everything the teachers should need to deliver the material effectively, and it's all in one place. Now, again, the curriculum is designed to provide a clear roadmap both for the teachers and the students. The goal was also to enable teachers to provide students with engaging curriculum-based projects that have an authentic objective in solving real-world style problems and which contain embedded academics. Now, the detailed curriculum with this set, if followed, provides the basis for what can be a standalone project-based robotics class, or again, an ongoing after-school activity if that's how you choose to approach it. Now, under this project-focused model, students are told upfront what they're going to need to learn and understand, and they are given a real-world scenario where they each take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to. And then they're provided with different tools and different pathways to help them achieve this goal. Now, among other things, students are going to be asked to perform research. And by this, we're referring to both research inside and outside of class. And they also have to learn the importance and all the things that are involved in the documentation process. For example, they have to know what a design brief is, and they have to maintain that. Maintaining a digital engineering journal and things of this nature. And they're also going to learn about collecting data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data. They're going to learn things like how to put data into graphs and other formats, and so on. Now, students are given a technical literacy task driven by the project. And fulfilling this task is going to require them to gain the knowledge and the tools needed to address it properly through research and exploration. They're then going to be asked to perform a series of specially designed enabling activities through which these students will acquire the necessary science, math, and tech-based skills. They're going to devise solutions to their tasks and create prototypes, again, using the advanced Fischertechnik modeling system. Students will then create and install the programming needed to control their robotic prototypes. They're going to document every step of the entire project. And at the conclusion of each of the project units, each group of students will be required to formally present their findings, including a demonstration of the programming and the prototype in action. Now, the curriculum itself comes in the form of a 576-page downloadable PDF document. Now, this document, which we are going to explore very shortly, contains detailed academic material for use in a classroom or an after-school setting, as well as full color step-by-step assembly instructions for building a series of 20 different robotic models. Now, these assembly instructions are also included both as the PDF in the documentation itself and also in a physical printed form. So besides the fact that the curriculum itself is this 576-page PDF, you are going to get printed instructional booklets in here as well. Now, as many educators and students may be new to the Fischertechnik building system, once again, the curriculum PDF also includes a helpful tutorial section right at the beginning, designed to help both teachers and students quickly get up to speed with using the system. Now, this section covers areas such as how to identify the various types of parts being used, learning how those parts fit together, and then walks everyone through the assembly of a very basic model just to get your feet wet. The curriculum itself is divided into 4 main project themes, and the project themes, or units, focus on competitions, programming, sensing and vision systems, and mobile robotics. Now, the curriculum as a whole is designed to provide enough academic material to cover approximately 70 academic hours. Now, according to program creator Tom White, there is a little bit of wiggle room here for educators to be flexible with this. Now, as he pointed out to me recently, a teacher could choose to leave some things out and use this, let's say, to fill approximately half a semester, assuming a daily class period of 50 minutes a day, 5 days a week, or they could add some hours of experimentation to easily bring it up to 90 hours or so if they chose to. Now, during the course of the 4 project themes, various activities are also addressed in various subject areas as touched upon. And this will include things like sketching, schematics, Ohm's law and power, an introduction to using the programming software and controller, working with flowcharts, open loop and closed loop programming, digital branching, edge triggered versus level trigger, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch, the digital phototransistor, and the digital trail follower, analog sensors, for example, such as the MTC resistor, the photocell LDR, the color sensor, and the ultrasonic distance sensor, an introduction to working with the camera attachment, using the camera attachment to detect motion, doing color detection, creating a ball finder where you use the camera on a swiveling base to locate the ball that you see there in the picture. Working with the line tool, the line following tool, working with encoder motors, and building the control panel. Now, I'd also like to point out that the curriculum for the Fischertechnik robotic competition set has also been designed to address some of the most widely recognized academic standards which are currently in place in the United States. And this is going to include the college and career readiness standards for math, science, reading, and writing, the NSES content standards, standards for technological literacy, ISTE standards, and the next generation science standards. Now, at this point, let's look briefly at some of the actual physical materials included in the robotics competition set. Now, as I mentioned previously, each set contains 670 parts components, and this includes a license of RoboPro graphic programming software, which is used with Windows-based systems, the powerful and compact Robotics TXT controller, the black controller unit you see there on your screen, and this has a full color touchscreen. It has Bluetooth and Wi-Fi connectivity. It has programmable sounds that you can use and lots of other great features. And there is also a Fischertechnik rechargeable battery pack and charging unit known as the AccuSet that are used for powering all of the models that you're going to be building, or that I should say the students are going to be building. Now, among the specialized components included is a gyro sensor, which is only available in this set. There are also 2 encoder motors, a USB camera attachment for building robots with vision systems, as I just touched on, a phototransistor, an XS motor, 2 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 3 ultrasonic distance sensors, an IR trail sensor, a photoresistor, a read contact, and of course, hundreds of other parts of various types for building your various model bodies, all which are packed in a sturdy grapnel storage box. Now, the set also includes printed materials, as I touched on before, such as the full-color 74-page pictorial assembly manual with instructions for building 7 different stationary and 13 mobile robotic models for a total of 20 models in all, and also included is a printed sample track and side fence that can be used for your soccer playing robots or line following playing robots or things of that nature. Now, essentially, with all this in mind, even if one chose to ignore the standards-based curriculum for whatever reason, you could still view this as the ultimate Fischertechnik mobile robotics set. Now, the contents of this one box will allow you to build all of the models found in both the Fischertechnik Robotics TXT Advanced set, probably the most popular Fischertechnik robotics set there is right now, and the Robo TXT Explorer set. Now, again, everything students will need to build all 20 models is included here, and that again includes the programming software, the controller, the power supply, and of course all of the various parts that are going to be needed. Now, as I've mentioned several times, this set will allow you to build 20 different robotic models. We're just going to take a very quick look at these models, just one per slide. Now, again, please note that these are, of course, not the only models that you can build with this set. And in fact, each of the 4 project themes in the curriculum that we're going to discuss will really only use these models we're going to look at as really kind of a reference. And instead, the curriculum is going to focus on requiring students to design and build their own original models to solve the core problems that are being put forth in each of the units. So that all being said, this one set will still include all of the parts required, as well as the detailed step-by-step instructions for building each of the models you're about to see. And these can be studied and experimented with on their own, or they can be used just to help students to explore and understand the concepts that, of course, they're going to draw upon for their own unique projects as they go through the curriculum. So just taking a quick look, you have a ventilating fan that can be built, a temperature control robot, an automated hand dryer, a traffic light simulation, an automated parking barrier with the arm that goes up and down, a swiveling security camera with an alarm, the cameraman, a basic mobile robot, which can be turned into a hindrance detector with a camera. You can make it into a trail searcher. You see it's using the camera attachment on there. Detection robot for detecting different objects, a soccer robot with movement control, and then you have a variation of the soccer robot where the camera is attached right on the robot itself. You have a basic tracked model, a trail searcher, a tunnel robot, and you'll see that there's different sensors and things that come up on here, such as the ultrasonic distance sensor with the 2 little speaker sides on there, the color detection, an explorer robot. This is using several sensors. I can see that it's got the line follower underneath, the rescue robot, and that's your 20. So now, as I mentioned, let's now take our focus our attention, I should say, on the curriculum itself. Now, at this point, we've already established the themes and the concepts the robotic competition set is going to help you address in the classroom. So now what we're going to do is we're going to take a look at the curriculum and exactly how it's structured. Now, each of the 4 project themes focused on in the curriculum for the robotic competition set contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline of what will be covered, the standards that will be addressed, the authentic project scenario, the daily teaching plan, supporting activities, and resources. Now let's start by taking a look at the table of contents for the robotic competition set. Now, the first thing I'm going to again mention is the section right at the beginning, which is designed to help new users of the Fischertechnik system to quickly get up to speed. Now, once again, the core building blocks used in the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts that are designed to work with it are designed for very specific purposes. Now, as a lot of this is going to be a little less intuitive and different than the simple stacking construction of many other building sets that students may have worked with, we've included this section right up front to increase your comfort with the system and to allow you and your students to get the most from your building experience. And I see there's a question in the chat window. I'm going to address that in a little bit. First off, moving along, there's a section showing how the parts fit together and discussing the pin and groove assembly method. There's a section showing you how to identify the different parts available from the core building blocks to the more specialized parts, things such as clip axles, girders, rivets, angle pieces, and much more. And for educators who are new to conducting a class of this type, there's a chapter specifically discussing project-based STEM education. Now, let me just look at, there is a question, I said it in the chat window here. It says, for the projects, is it follow the assembly guidelines? In other words, how much is it like putting together a Lego set compared to designing and building a trail follower from scratch? Just to make this clear again, there are 2 aspects to this set. The models that I ran you through, once again, there is an assembly manual to build those specific models. So if you chose to ignore the curriculum, and again, this is ignoring the curriculum, you could still build all of those models in the instructions. The way the curriculum is designed is we're going to go into right now. It is designed not so that the students follow the directions and build a robot that someone else came up with in, you know, the design lab at Fischertechnik, Germany. It's going to be creating and designing their own robot. What you want them to do with those sample projects that we ran through is maybe they learn something about how you're working with the track system, about how a color sensor or what have you is used. And so they can incorporate that into the projects that are going to be presented in the curriculum itself. So once again, no, you're not having everybody build the robot on page 32. And, you know, there's something to be gained from that, but for the purpose of the curriculum, it doesn't serve that purpose. It's the purpose here is going to be how well they take all the information and go off on their own, and how well they use their creativity and how effectively they design things. We'll of course get into this. Anyway, moving right along, after I mentioned this little section here, let's see. If I got off my path, bear with me a second. Okay, so after this introductory section, after there's the section that walks you through working with the Fischertechnik system and the project-based learning and what have you, we have 4 theme units, which I introduced earlier in the presentation. Again, the 4 theme units are competitions, programming, and sensing and vision systems, and mobile robotics. Now, in the following slides, I'm going to share some examples from each of these 4 theme units to show examples of just how they address the structural format, as I touched on a few slides back. And just because I see one more question coming up, is this a 2-student per set arrangement where I would need to purchase 15 sets for a classroom? And I'm assuming, of course, you're talking about a classroom of 30 students. This is a 2 to 4 student arrangement. I say that because when they're working on these projects, and you ideally do want them working in small teams. So I would probably lean towards teams of 3 to 4. It's going to depend how quickly you want them to get through this, because, for example, when you're building different types of things, let's say you might have to build a drive system, you have to do the programming, you have to work with different sensors or what have you. There should be enough things where if you have several students working on different aspects of it and coming together, doing trial and error in different aspects or research or whatever, that having several students can work, as opposed to just having 2 per set. I would say the 2 per set strictly refers more to other items that we offer, but for something like this, because there's going to be enough moving parts, no pun intended, to work with here, conceptually and otherwise, that I think you definitely have enough for the students to do here. So I would really aim more in that 3 to 4 student per set window. Anyway, is there a pacing guide? Not really. Well, there is, in the sense that we'll get into this here too. And I'm going to get back to the program itself as opposed to answering the chat questions right now. But you'll see that as we get into this, when we get to the daily plan, that's essentially going to be your pacing guide. It's going to tell you that today we're going to do this, and the next day we're going to do that. And like I said, we're going to get into that just now. So anyway, getting back to them, each theme unit will start off with a section outlining the purpose of the project to be addressed in that particular unit. Now, the section we have on the screen right now, in this section, is going to be designed to spell out for students a clear answer to the question, of course, why we need to know this, as well as what skills we help to develop. Now, in the example shown here, as you see, it's a unit on programming. The focus here is going to be on students designing and implementing a program to control an automated system. Now, this is followed by a section listing the concepts to be addressed in this particular unit. And once again, you're going to see these things that we're going to go through right now, the purpose, the concepts, the outline, etc. These are going to apply to each of the project units. And the same thing when we get to that daily plan or pacing guide, which, however you might want to think of it. These are included in each of the units as you go through the curriculum. So here's the section where the concepts to be addressed in this unit are all spelled out. And these can really be thought of as the big ideas that students should learn from this unit that are going to be useful and vital for them to understand and know. And of course, not things that are just useful for them to use for completing the project, but also things that you want them to draw upon as they move forward in STEM fields of study. And of course, you hope eventually STEM related careers. Now, this particular section, is you'll see on the screen, is taken from a unit on competition specifically. And because of that, it provides an overview of some of the areas that students will begin to learn about and explore here. Things like control statements and linkage mechanisms and automated systems, sketching, and so on. Next up is the outline. And this is found in 3 of the 4 theme units. Now, in the outline, it's clearly spelled out more specifically what's going to be covered in that particular unit. Now, the example pictured here is again taken from the unit on programming. And so, of course, you see things listed here such as documenting programs, working with object blocks, working with Boolean mathematics, loops, branching, data, and so on. Next up, we enter the section where each of the specific standards to be met by each particular project unit is spelled out, which of course provides the educational justification for the project they're going to be working in. Now, we often get asked if our curriculum-based programs meet the standards for a particular state or a district. And, of course, while we would love to be able to state that they do, with 50 states and so many ways that districts label things and what have you, being able to clearly align to all of these individual standards, of course, just isn't practical or feasible. So with this in mind, what we've done is to select the most universally accepted standards that are currently in place in the United States. And with this in mind, first up, we have the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. Next up, we have science standards beginning with the NSES content standards for K to 12, standards for technological literacy. This is followed by the ISTE Technology Foundation standards for students. I see another question coming up. I will get to it after. Next up is the assessment section with links to both general course rubrics as well as rubrics related to that specific theme unit. After that, we have the essential question. And this can be thought of as the major idea to be explored in this unit. Now, in this example, taken from the unit focused on sensing and vision systems, the question being put forth is, how do automated devices sense and operate in the world around them? Now, the student scenario, which comes up next for each unit, gives the students an opportunity to explore that particular unit's essential question. And this is done in the context of a real world problem that the students are given to solve. And it helps to also provide an answer to where will I ever use this? Now, in this particular example, students are told that they are part of a technical sales team working for an alarm company. And just a quote from the scenario that's on the screen right now, quote, "Your company has been trying to increase sales to the museum alarm manufacturers. The decision has been made that sales could increase if there was a web page created that had a section for each sensor, a description of how it works, and a sample alarm circuit that others could use to base designs from. You will have to build a prototype of the situation your alarm will monitor and list conditions you will monitor. A section on suggested calibration is also necessary. Your team has been charged with this project. Your team will brainstorm what the web page should contain and how it should be laid out. Your team will conduct internet research to discover how sensors work, what other companies do to create data sheets, and how to create simple web pages using Microsoft Office. Once the research is done and the enabling activities are completed, the team will design their sections for the web page. Any software created for the web pages should be documented completely, so another team can easily figure out the work you have done. All work should be documented in the engineering notebook. Students will devise alarm circuits utilizing at least 3 methods. Each sensor will have a page in the manual, and the sample alarm circuit should explain how each sensor works and sees things the others do not. Students will present their online files along with a presentation of their prototypes in hopes of landing a sales contract," end quote. Now, that's just one example, and obviously that's built on more about understanding certain things about these sensors and what have you. But in another scenario being put forth in the programming theme unit, the student groups in that case will be tasked with designing and building an elevator that will need to function in a particular way, such as, for example, how the elevator would respond if a call button was placed on different floors at the same time. For example, let's say the elevator's on a middle floor and someone pushes a call button on a bottom floor and somebody pushes a call button on a higher floor at the same time. You, of course, have to create a protocol in the programming for how the elevator responds, things of that nature. Now, each student group will be tasked with designing or programming protocol for how that elevator is going to navigate such occurrences. And again, the fictional client's requirements, as in the example I showed you here, or in the example I just mentioned with the elevator, the fictional client's requirements are all going to be clearly spelled out. And the students will be required to create a program to address these specific needs or create a physical prototype using, of course, the Fischertechnik components. And at the end, whatever the scenario is, the students have to present a presentation for these clients that, of course, if there is programming or a prototype, they have to show how those work and demonstrate those as well. Now, after this is the daily plan, which clearly spells out the expectations as students work through the project and the student scenario. Each day of the plan is going to act as a guideline to spell out specifically what the students are going to need to look at that day and what they're going to need to accomplish. Now, you'll see that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, they're going to have links that show them what's going to be required in the design brief that I keep mentioning, or in the engineering journal, or what have you. Now, again, each day has a different task that's going to be addressed, a different activity that's going to be performed, or a different question that's going to have to be answered. Now, in the example that you see on your screen right now, again, taken from the unit on programming, on day 7, there is a discussion topic. And in this case, the discussion topic is, how does my dishwasher know when the dishes are clean? So, of course, your dishwasher doesn't know when the dishes are clean, but of course, it's programmed a certain way and it has to go through certain cycles for a specific period of time. And so in this instance, the teacher can lead a discussion where this idea can be explored. Now, other things covered in this unit in each day of the daily plan will include things like how data is taken from a sensor and recorded, or how files can be taken from the RoboPro programming format and put into an Excel format to be worked on and then put back into RoboPro, and so on and so forth. Now, as students work through their daily plan and on their answers to each of these student scenarios, they're also going to be required to perform research, as I touched upon. They're going to have to do a lot of trial and error experimentation. They're going to have to document every aspect of the process, which again means maintaining a design notebook and an engineering journal. Again, they're going to design and build a working prototype using Fischertechnik, and also create and deliver a presentation of this prototype in action, or also the programming is it's going to be required with this. Now, the curriculum is designed so that each day in the project theme will build on the day before it, and each activity is subsequently more complex, and of course, along the way, provides the information that students are going to need to draw upon to successfully complete the project at hand. And the idea behind it is that this really helps to reinforce the concepts for students, and it ties everything together in an organic and meaningful manner. Now, there's also a section at the very end of each unit with various additional materials that are all collected. And this can include vocabulary words, it can include links to carefully vetted web-based resources, videos, Word documents, PDF files, PowerPoints, and much more. And once again, each of the 4 project-themed units will follow the same structure as we've just seen, including the standards, the rubrics, the daily plan, the resource materials, the links, and so on. Now, as I mentioned before, there are also numerous links throughout the curriculum for more information on specific topics, which are also collected in one section at the end of the robotic competition set curriculum. And this is going to include things such as links to sketching, working with schematic drawings, Ohm's law and power, an introduction to working with the RoboPro programming software, and becoming familiar with the TXT controller, which is used to control these robotic models, working with flowcharts, open loop and closed loop programming, working with digital branching, logic levels and programs and triggering, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch and the digital phototransistor, and also the digital trail follower. Next, we move on to analog sensors, such as the NTC resistor, the photocell LDR, the color sensor, and the ultrasonic distance sensor. There's an introduction to using the camera attachment, using the camera to detect motion, working with color detection, using the swiveling camera as a ball finder, learning how to have the robotic models follow a line path, learning how the encoder motor allows for precise control of movements, and building the control panel. And again, is documenting the entire process is a major focus of the curriculum. There's another section included at the end of the curriculum that spells out the proper procedures for record keeping of this sort. Now, this is designed to help students to develop proper work habits and embeds technical literacy into the projects. Now, this is going to include requirements for maintaining an engineering notebook. The elements that make up the design process are outlined. Examples of design documentation are discussed. The problem statement is explained, including its components, the vision statement, the issue statement, and the method statement. Points to be summarized in a design brief are discussed. The elements of testing protocol are outlined. And finally, the requirements or the required components for an engineering report are also outlined and spelled out. And following this is a section where we collect the step-by-step assembly instructions for each of the 20 models, which again, as I mentioned, are included in a printed format inside the set. And again, these are just used as something to draw upon to learn about the different areas, things that they would hopefully incorporate into their own models. And that's everything you get and everything that you can explore with the Fischertechnik Robotics set. And just to go back, and before I go into our summary here, just to get that last question that I didn't get into here. Let me just make sure. Okay, just checking, is it any standard programming language or a specific one? And by that you mean Python, Java, C, or something specific to our processor. The Fischertechnik TXT controller, as you see here, like the one sitting in the box right there, as I said, uses the RoboPro programming software. RoboPro is essentially graphic programming software. You may have seen me show one of the slides a little bit ago, where it's the flowchart style design, where you use the different icons and you link them in a drag and drop fashion to create the program. And you can, of course, create loops or what have you. That is the standard programming that you use with the Robotics TXT controller. If you decided to go off the grid, so to speak, and use something else, like C or what have you with the controller, you do have that ability as well. That's not something that's supported in the curriculum or the documentation, but you can do that. Yeah. So moving right along, just to summarize. Hang on a second. I went off the screen and it doesn't move. There we go. Okay. So just to summarize, the Fischertechnik robotic competition set contains everything you need. It's going to have all the parts, the RoboPro graphic programming software, as I just mentioned, the compact and powerful Robotics TXT controller, the rechargeable AccuSet battery pack and the charging unit, and the step-by-step assembly instructions for building 20 different instructional models. And as well, of course, the complete and highly detailed day-by-day curriculum that we just went through. And the curriculum included in each set is yours to use this year, next year, and of course, for many years to come. Just, we want to stress, there are no additional fees. There are, of course, no subscription charges. Everything you need is included. When you buy the box, you get everything there. Each set is designed for use by teams of 2 to 4 students. Again, if you ask me, I'd probably say lean on the 3 to 4 students. So it's easily scalable. Using that example, if you had a classroom of 20 students, you could use as many as 10 sets or as few as 5 sets, depending upon your budget. And of course, again, how quickly you want students to move through the material. Again, it's also all reusable. Students can build a model, perform the experiments, take it apart, and they can build another one. Of course, if you ever did need any odd parts, or if you needed any replacement pieces, you can purchase those parts or pieces individually in whatever quantity you choose or need directly from the Studica website. Now, again, the Fischertechnik robotic competition set is designed to make it easy for educators from any kind of background, even a non-tech background, to offer a hands-on project-based learning experience for their students. And again, Project-based is what experts agree is one of the most excuse me, I'm tripping on my tongue today. It's one of the most effective methods known for teaching STEM concepts like robotics. And as you probably saw this slide before, pricing starts at just $699 per set. Of course, quantity pricing for classrooms is available upon request, so you can request that from us. So on that note, here is the question slide. If you have any other questions that we haven't touched upon, you can just simply type them in the chat window. I would say speak them in real time, except I'm not going to mute everybody, sorry. It just works better this way. But you can just type it in the chat window or the question and answer window, either of those. Also, you'll see my email addresses up there. If there's anything else that comes up that I didn't address, or you just didn't ask at the time, you can write down my email address. That's my direct email, LanceZ, L-A-N-C-E-Z, @Studica, Studica.com, and I'll be happy to address that for you. So if you did have anything else, I think we touched upon most of the stuff. Well, good. I'm happy that you'll consider it. So on that note, assuming you got my email address, of course, if you wanted to get more information, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative, you can call us directly. If you're here in the USA, you can call us at 888-561-7521. If you happen to be located in Canada, you can call our Canadian office at 800-561-7520. Of course, you can visit our webpage, as you see there, the www.studica.com/Fischertechnik-education. You could type all that in, or if you basically go to the Studica page, there's a little Fischertechnik icon at the top, and you can pretty much click on that and it'll take you to the right place. And of course, there are two more email addresses. Mine, once again, LANCEZUR, or LANCEZ @Studica.com. Or you can just use the more generic info@Studica.com. If you can't remember my name, info@Studica.com is easy enough. Just let us know where you're at, what your question is, and we'll be happy to help you out. So with all that being said, again, thank you for attending. And of course, if you have any questions about this or anything else that I touched upon, the other curriculum-based sets, the simulation and training models, which we have both 9-volt versions for use in a classroom using the RoboPro software, or if you're looking for 24-volt versions of simulation models to teach PLC programming, things of that nature. If you're going on the more industrial end, we have those available as well. We have webinars on all these things. We have a lot more information. So if you have any other questions, again, just feel free to contact us. But on that note, thank you very much for taking the time to attend, and I look forward to hearing from you soon. Be well.